Okay. Hello everybody, welcome to frankvhunt.com and a little introduction about electricity. I'm going to start out today with the beginning, which is the definition of electricity. A lot of people say, what's electricity? It's like you think of it as light, but it's not really light, of course, but you'll see that in a minute. What I like to call the definition of electricity, when I come to trying to explain that to people, I always fall back to the analogy of water, the flow of water, and how that all happens in our planet, on our planet. We get the sun shining on the ocean warms up the water, the sun warms up the ocean, the water gets warm, and it starts to evaporate, becomes invisible. So now we got movement of water, but we can't see it. So it goes up into the air and gets high enough and it cools, and so it becomes a cloud. This cloud traverses across the land, kind of follows this path following the wind, and as it comes up near the mountains, it maybe starts to collect there and develop into a collection of moisture, which then condenses and becomes rain. Now you got these drops of water that you can see. These drops of water come against a mountain, they follow this path, they come down a little stream, they come down a bigger stream, they come down a river, and eventually they're working their way with all of this gravity force of this weight of water coming down to the ocean at sea level. That weight, that force, that energy is all dissipated, and now we're back at the ocean. The next morning the sun comes up, heats up the ocean again, more moisture comes up, travels along this path, comes up to the mountains, comes down the mountains, comes down the stream, and you could use that movement of water to like turn a water wheel, back like they did 100 years ago. So that can create some work by the force of water moving. So electricity like that, except you can't see any of it. What happens is you get something to create the electricity to get them stirred, electrons to get them stirred up, right? Those electrons start to flow up on a path, like a wire, we would call it. They flow along this path, they go through some kind of control mechanism which lets the electricity flow through or not. It flows through this path, comes to, like in the case of a light bulb, a small little device that maybe heats up and starts burning inside and creates some visible light, and the electrons flow back down to where they came from, much like the water did, flow back to the ocean, goes back to the battery source or the source of the generator. That generator is stirring up those electrons, whether it be a windmill generator or water wheel turning, something to make electrons move. So the electrons are moving along this path that we call a wire, goes through the control mechanism, comes back, goes through the light bulb, creates some kind of light, and then follows the path back to where it came from. So this path always happening, and we don't care how long this path is because the electricity travels so fast, 186,000 miles in like 1 second. So 186,000 miles, you think like, how far is that? Think of the globe as being like 24,000 miles around, 6 times around the whole world in 1 second. So sometimes that boggles people's minds, and they think like, how can that be? Let me give you another analogy, going back to the water. Suppose you had a water hose full with water. You fill this water hose up with water, and it's all the way full to the brim. On both sides you got this water hose hanging, and it's full of water, but you force one more drop of water into that water hose. What's going to come out the other end? 1 drop of water, right? You're going to need some kind of force, some kind of power, some kind of something to push that drop in. Well, suppose you had nice clear blue water in the hose, and you dropped in 1 drop of red water. What comes out the other end? Is it a red drop? I don't think so. It'd be like a blue drop, right? It'd be not the same drop of water. But you need some force to take this 1 drop, bump it into the next drop, bump it into the next drop, bump it into the next drop. You got thousands and thousands of drops of water in here. And with that energy of forcing that water drop in, it bumps against the next drop, bump against the next drop, bump against the next drop, bump against the next drop, and eventually that 1 drop drops out. That's how electrons flow. You get something to start the electron to flow. You bump into 1 electron, it bumps into the next one, bumps into the next one, bumps into the next one, and then it gets to the light bulb, and it's got this tight place to go through, and so it heats up, it's creating this heat in here, it's creating this visible light, and the electrons flows back on another wire, all the way back to where it came from, where the force forces another drop in, another electron, and it's really bumping against the next one, bumping against the next electron. So that's kind of a little definition of electron in a word, in a sentence you might say. It's the flow of the electrons that is the definition of electricity. Alright? So let's see what I'm going to be talking to you about next time. Is that how are we going to control this flow of electrons? Like we got electrons flowing in lightning all the time. It's like out of control. We're going to figure out a way to control it. So be sure to come back next week. Thank you for stopping by.